Hello, welcome to Pre-Cal Lecture 1.11b, where we're going to continue our discussion of working with rationals. So our first example, we're going to get a common denominator, invert, and multiply. So we've got here 2 minus 2 over t. I want to get a common denominator on both the top and the bottom. So I could multiply that 2 by t over t. And the same thing here on the bottom. I can multiply that 2 by t over t. That's just a clever version of 1, right? And so you would have 2t over t minus 2 over t. And we'll put those together in a minute. We have 2t over t plus 2 over t. So putting these fractions together, I would have 2t minus 2 over t on top, and then 2t plus 2 over t on bottom. Now let's flip the bottom. So we've got 2t minus 2. I'm rewriting this top fraction over t, and then I'm flipping the bottom and multiplying. So it would have t over 2t plus 2. Well, now the t's will cancel out. And we can get all this together as 2t minus 2 over 2t plus 2. Now, when we cancel those t's out, we have to do our proviso. T cannot be equal to 0. All right, so we're almost home here. What could we do? We could factor out a 2 out of the top, and then you'd have t minus 1 left. And then we could factor out a 2 on bottom, when we'd have t plus 1. Those 2's will cancel, and so this ends up as just t minus 1 over t plus 1. But we have to add another condition. T cannot equal negative 1. All right, so it doesn't bother me if you put those in two different places, okay, and just write them down as you come to them, those provisos or domain restrictions. Okay, let's do another one. We're actually going to do the same example again, but I'm going to show you kind of a cool way to do it and save some time and space on your paper. So let's say that we could clear the entire denominator by multiplying by a different. So on the last one, we kind of did the obvious version of 1. Okay, so we're going to rewrite this problem. So we have 2 minus 2 over t divided by 2 plus 2 over t. So instead of really working only with the top separately and the bottom separately, let's try to work with both at the same time. How about, and I'm going to write it real big, we multiply by t over t, the whole thing. Okay, that's just 1. But if we multiply by t over t all in one pop, then we're going to do 2 times t, so that would be 2t. And then t times 2 over t, the t's would cancel, and you're just going to have minus 2. So we skip that whole middle section. And then we would have 2t on bottom, and then t times 2 over t, the t's cancel, and have plus 2. Okay, so if those t's cancel out like that, we can't have t equal to 0. So I'll go ahead and write that out. And now we can factor out the 2, and we would have t minus 1. Factor out the 2 on the bottom, we have t plus 1. The 2's cancel, and you have finally you have t minus 1 over t plus 1. T cannot be negative 1, right? And so we skipped a step on that. Let's try another one of those where we kind of work with the whole complex fraction all at once. Let's say we have 1 plus 1 over x. And what makes this a complex fraction is we have, you know, a non-fraction and a fraction together, a non-fraction and a fraction together, over 1 minus 1 over x squared. So, you know, you could multiply this by x over x and then put it together, multiply this by x squared over x squared and put everything together. That would be fine. That would work. But we could also do like the last one and come up with a clever version of 1 that would get rid of both of these fractions, okay? Because that's what we want to do. We just want a singular fraction, something over something, not a fraction over a fraction. How about, so if we did x over x, so I'm gonna write this out, but I'm gonna erase it because it won't work. So x times 1 over x just is 1, right? But x times 1 over x squared just gives you 1 over x. That doesn't get rid of this fraction. So how about we do x squared over x squared? Okay, that's still legal. That's just a version of 1. But now we get rid of this fraction and this fraction. So you would have x squared times 1 is x squared, and then x squared times 1 over x, the x on bottom cancels, and you would just have plus x. And then the x squared over x squareds cancel here. So you have x squared because you're multiplying it by that 1, and then minus 1. Okay, and then of course, since we canceled those, x can't be 0. Okay, we can factor out an x on top, and I would have x plus 1. And this is the difference of two perfect squares, so that'll factor into x plus 1 times x minus 1. So before I cross everything out, I'm just going to go ahead and put our domain restrictions. It can't be 0 or plus or minus 1 because negative 1, positive 1 would make the bottom 0. And we'll cross this out, and we're left with x over x minus 1. So if you can do it the long way and do x over x squared over x squared here, but we could also do x squared over x squared the whole thing. And that kind of saves us some consolidation and some simplification. It kind of moves us ahead in the problem. All right, I got one more that looks terrible, but you know, we have to try to work them no matter how they look. Okay. So our example here is, we've got 1 over x plus 1, and this is just, we're simplifying. We're performing the operation, minus 1 over x over 1 over x. Okay, so first of all, let's consolidate this one. Now we could multiply this by x over x, this by x plus 1 over x plus 1, then we put them all together. But hey, how about we use that little trick I showed you in the last lecture where we get a common denominator by multiplying, because there's 2 of them. This works really well when you have 2. Multiplying the 2 bottoms together. So we'd have x times x plus 1. So that's our common denominator. And then we're going to bring this x up here. And then it's a minus, and we're going to bring this x plus 1 over here. But we have to put it in parentheses because it's a minus, because we're going to have to distribute that negative sign all over 1 over x. You can't forget that. we'll deal with that at the end. Okay, let's go ahead and make this x minus 1 over x times x plus 1 over 1 over x. And then x minus x, you're just left with negative 1. All right, the x's cancel over x times x plus 1. And now I'm going to flip and multiply. So times x over 1. So now I've got negative x over x times x plus 1. Now I'm going to go ahead and put our domain restriction. X cannot be equal to what? 0, because that would make the whole bottom 0, and negative 1. Okay, now we can cross out. And what's left? It's a negative 1. Don't forget your negative sign. We can cross out this x because it's not attached to anything. This isn't attached to anything. So this is just an x over x plus 1. So pretty cool. This is really just a terrible way of writing this, okay? With these provisos, of course. All right, your homework is to finish up worksheet 1.11, do 7 through 10. They look a little nastier, but you can do them. Just take your time. So our homework is going to be worksheet 1.11, 7 through 10. If you need to do those on the back of the worksheet or on your own paper, that's totally fine. You don't have to squeeze them into those little spots. All right, good luck on that. I'll talk to you on the next one.